We begin our journey inside London's Science Museum, a place where the history of science, technology, and human invention surrounds us. As we move through the museum, extraordinary machines and historic objects reveal how people have transformed the world around them. From transportation to engineering, and eventually to the exploration of space, every gallery tells another chapter in the story of human curiosity. A glowing globe draws our attention before we return to the technology of an earlier age. We pass a classic automobile, looking closely at its design, its controls, and the engineering hidden beneath its body. Nearby, the historic speedboat Miss England represents another pursuit, the search for greater speed and performance. As we continue, the museum opens into a vast industrial landscape. Massive machines, engines, and mechanical systems stand around us, revealing the physical scale of an age when engineering was transforming everyday life. These machines are more than historic objects. They are evidence of how ideas became technology, and how technology changed the world. We move through the central hall, surrounded by aircraft, vehicles, and enormous pieces of engineering suspended high above the visitors. The contrast is remarkable. Delicate objects are displayed below, while enormous machines rise above us. The collection shows that transportation, industry, and engineering did not develop separately. They evolved together, driven by the same desire to travel farther, move faster, and build something better. As we move deeper into the hall, the scale of the collection becomes almost overwhelming. Aircraft hang overhead, while historic vehicles and machines fill the space below. The camera returns to the historic vehicles. A classic automobile stands beside one of the museum's distinctive boats. Road and water may seem like completely different worlds. But the engineering ambition is remarkably similar: to create movement, to increase speed, and to push technology further. Now the Miss England comes fully into view. Its long, streamlined hull dominates the display. From the outside, the design appears simple. But as we move closer, the cockpit, instruments, and mechanical systems begin to reveal the complexity hidden within. Every dial and lever had a purpose. Every part was designed to turn engineering into performance. Around the boat, photographs and information place the machine within a wider story of competition, innovation, and technological ambition. We then move through more historic displays before returning to the museum's central hall. The vast space opens once again. Aircraft above us, vehicles around us, and generations of technology displayed side by side. And then, almost like a change of atmosphere in a film, the light ahead becomes blue. The word space appears before us. We have reached one of the museum's most remarkable galleries, a place devoted to humanity's journey beyond Earth. The atmosphere is darker now. The exhibits are illuminated against deep blue surroundings. The story is about to leave the ground behind. At the center of the gallery stands an extraordinary spacecraft, the Apollo 10 command module. From a distance, its shape is unmistakable, but as we approach, the details become more revealing. The windows, the protective exterior, and the compact structure designed to carry astronauts safely through space. Apollo 10 flew in 1969 during the final preparations for humanity's first landing on the Moon. Its mission tested critical systems and procedures before Apollo 11 made history. Standing beside the spacecraft today, it is difficult to imagine the extraordinary journey this small capsule was built to survive. Extreme temperatures, the vacuum of space, radiation, and the intense heat of returning through Earth's atmosphere. Yet this compact spacecraft carried astronauts across hundreds of thousands of kilometers and brought them safely home. Nearby, the story becomes more personal. Displays introduce astronauts and the people behind the missions. Among them is British astronaut Tim Peake, whose journey to the International Space Station became an important chapter in Britain's contribution to human spaceflight.
Through our atmosphere, as they travel through our atmosphere really quickly, they burn up. So by the time they hit the surface, they're usually much smaller. We are not nearly covered in as many craters as Mercury. Mercury hasn't got this atmosphere, it hasn't got this cushioning. So when it gets hit hard. Okay, but there's something else that happens with Mercury because it hasn't got an atmosphere. Because I said that Mercury is the closest planet to the Sun, therefore you'd expect it to be the hottest. But it's actually not the hottest planet, because on average, Mercury can have temperature differences of up to about 300 degrees from daytime to nighttime. So during the day it can reach about 400 degrees Celsius, but what happens is when Mercury spins, it spins on its axis, just like our planet here, okay? And when it's facing the Sun, we call that daytime, and as it spins away from the Sun, which we call nighttime, it turns away from the Sun, it can't hold in all that heat. All that heat it got throughout the day can't stay on the planet because it hasn't got an atmosphere to trap it. So instead what it does is it releases all that heat into space. So it can get really cold on Mercury. Obviously, in comparison to our night times, it's still probably pretty hot on Mercury. But in comparison to its sort of 300 degrees Celsius, it is much colder at night time on Mercury. Instead, our hottest planet is the second planet in the solar system. Okay, I think you guys were talking about it earlier. I heard you sort of scream it. It is called Venus. Now, Venus, don't tell the others, Venus is my favourite planet. Okay, Venus is my favourite planet. Not only is it the only planet named after a woman, it's named after the Roman goddess of love, but Venus is my favourite planet because it has a very odd nickname. We often refer to Venus as Earth's evil twin. And I just think that's really fun. It's really fun, it's Earth's evil twin. The reason we call it Earth's evil twin is because it's a very